Next assembly we're going to discuss from BAVCO is the Model 6C. The Model 6 was their original version, then they changed to some construction changes to the Model 6C, which was a new improved design. This one was produced from about mid-60s to 1978 when it was discontinued. Rubber repair parts are still available. Hardware parts have been discontinued or limited to stock on hand. The 6C was a bronze body unit in sizes 1 through 6 inch and then cast iron in 6, 8, and 10. In other words, 6 inch you could get either a cast iron version or a bronze body version. The 6, 8, and 10 inch were a galvanized coated body. That's how it was produced in the early years. And let's take a look at one other thing on the 6C. What I wanted you to see was the picture of a 6C. On your far left, here's a 1 inch, here's an 1.5 inch, and here's an 8 inch version. All three are dramatically different looking in construction. In other words, most backflow assemblies, when you see a 4 inch, 6 inch, or 8 inch, other than them being larger, it's hard to tell the difference between them. But the 6C was unique in that every size had a different appearance in the way it was constructed. And also when we get to talking about the check assemblies, the contained springs were different depending on which size and which version you had also. But this is the BAVCO Model 6C. Let's see what it looks like inside. I have a 1 inch example here that I'm going to show you. First thing we're going to do is talk about the check assemblies. The shutoffs would be normally mounted here. Usually we mount it with unions so that it could be repiped easily in the piping configuration. But for a 1 inch assembly, you can see it's a relatively large compared to modern day assemblies. So going to take it apart. This is the second check cover. Screws into the cover, the body. Cover comes out. Check spring. Disc holder in one piece like this. The first check on the 1 inch, like the second check, unscrews from the top, obviously heavier spring load, cover, spring, and disc holder. So these are the check assemblies of the 6C. So here's what the two check assemblies on the 1 inch looks like. Check seats are cast in the body and are not replaceable. They had a flat profile, meaning the top of the seat was flat. Now, as I mentioned earlier in the reference manual, that each of the backflow assemblies look differently in the 6C series, this being a 1 inch, made all the way to 10 inch. They had either an uncontained check assembly, meaning like this one, where the check assembly, the spring was not contained. This is what the second check would look like inside the body, so I obviously had to release the spring tension. The larger assemblies, and here's what the 3 inch first check looks like, comes out of the body like this in one piece, did not have to have the spring released for the average repair. For the average repair, one nut on this side would hold the disc into the disc holder like this. So, various sizes on the 1 inch, as I said. Both checks had an uncontained spring, meaning that when I took the cover off, the springs came out. 1.5 inch, the first check was contained, second check was not. 2 inch, first check was contained, second check was not. 2.5 inch. Both springs were contained. 3 inch, first check was contained, second check was not. 4 inch, same story, first check was contained, second check was not. And then the 6 through 10, both checks were contained, spring was contained for the check assemblies. So whether you had the contained spring assembly, or like you see here, the uncontained spring assembly, one bolt or nut was removed to go ahead and change the disc on the check assemblies. Now, the relief valve. This is our 1 inch, again piped into the water piping system like this. This flange is just a stand on the bottom for demonstration purposes. In the old days, relief valve drains actually had a pipe thread on them, this being a standard 3/4 pipe so that you could run it to the drain. For obvious reasons, we don't have pipe threads on the bottom of bodies anymore. We have them on the bottom of air gap drains so that we can put an air gap on the exit. But in the old days, they didn't think about that, and they actually had pipe threads coming out of the bodies. So to go ahead and remove this one, we have to remove our drain system, whatever type it was. That would expose a large lock nut on the outside. So what you're looking at is, and here's another relief valve stem assembly, mounted in the body. It would be this lock nut mounts it on the outside of the body where our drain would be connected like this. So you see what it would look like inside the body. So to disassemble the relief valve, we have to remove the cover from the bottom first, but loosen our lock nut as I just did. And by loosening that lock nut and removing it like that, allows us to take the relief valve out through the bottom and put our relief valve stem assembly for repair. So this is what the relief valve stem looks like outside the body. Here's our lock nut, which held on the outside of the body where our drain was connected. You can see it was sealed by a gasket here. To disassemble the relief valve, you'll notice on the back side we have a clamp bolt nut with an Allen head recess in the middle. You would place your Allen head wrench in there and loosen the nut. Obviously I've already got it loosened for demonstration purposes. Once we loosen that nut, we would release our relief valve spring tension from the bottom. We had a double relief valve diaphragm. And this kind of goes back to the late 60s and 70s era when a lot of backflow, not backflow assemblies, but any water valves used to have double diaphragms for security reasons. And they would have two diaphragms like you see here. So there is a upper diaphragm plate, or a lower diaphragm plate and an upper diaphragm plate. And the two plates were not interchangeable. If you can tell, one was thicker and one was thinner. And this being the lower plate and this being the upper plate, the thicker plate went on towards the bottom of the relief valve, which would be like this. Our relief valve diaphragms, as I said, there were two identical diaphragms. It utilized an internal relief valve sensing line, so you see the extra hole in the diaphragm right there where the sensing line went through the body. The 1-inch body, as we see here, was a brass body, so we didn't have any problems with the problems they had with galvanizing and cast iron bodies. They made from 1-inch up to 4-inch in standard in bronze. They had a 6-inch through 10-inch standard in cast iron galvanized. They also made a 6-inch in bronze, which they didn't sell too many of. Anyway, back to disassembling the relief valve. So backing down to see our parts here, we have our two plates and our diaphragms. Next would come off would be our relief valve spring. That would expose this piece here called a clamp bolt, which was held in by a bolt on the inlet side. Unscrewing my clamp bolt, had a relief valve disc mounted in it right here. The bolt would protrude through the next side here. It goes over here. Now, you'll notice we had on the top portion here with a small little hex. This was a key area that make us taking the assembly apart. There are actually two relief valve seats and corresponding two relief valve discs. One seat sits right here. The second seat, taking a spanner wrench, would remove our upper relief valve seat right here. So there were two relief valve seats and two relief valve discs. So the way this would sit inside that body was putting the two discs together like this with our two seats together like this. Now, this upper seat would screw into this piece called the relief valve housing. Now, you can tell as I screw it in, I'm changing the height of that seat in relation to this seat. So it was absolutely critical that we had to mark these seats to know exactly when those two seats were equidistant, because there was no adjustment on the discs. Therefore, we had to get the seats at the exact point where the two of them were the same equidistant as the two discs. We'll talk about that when we put it back together. So, relief valve seat, O-ring on the relief valve housing. Now, the oldest version of this particular design did not have an O-ring on the relief valve seat, and it used strictly a pipe thread, which was a little harder to get that exact end-to-end measurement. But most of the ones that were produced did have the O-ring design. The first couple years they made it like this one did not have that O-ring on the seat. Now, go ahead and replace the rubber parts. The biggest problem with this design was going ahead to align those two seats. So, first thing we had to do, replace our relief valve disc and our relief valve spacer. Put our spacer inside our housing. Take our relief valve seat, thread it into our relief valve housing, and just get it hand tight at this point. Now, at this point, we're going to go ahead and put our stem assembly back together. And what we're going to do is just kind of get it hand tight, just to kind of get it to a starting point. Because what we're going to try to do now, and it's highly suggested that you mount this onto a vise, putting a spanner wrench between those 2 points on the vise like this. And what you're going to do is mount that spanner wrench to hold that bottom seat stationary. Don't clamp this into the vise. A lot of people just put it in here, clamp it in, and they end up crushing this. So you put your spanner wrench across here, put the spanner wrench in the vise, having the vise hold the spanner wrench. What I'm going to do now is I want to screw this seat into the point that it touches that upper disc. How am I going to know when it's at the right point? Well, if I thread it all the way up in, it'll just touch this, and I'll just see this move just a hair. So what you want to do is make a small little pencil mark right about here where you can see easily. And as you go to mount this in that vise like that, you're going to put a wrench on the outside of the housing right here, and you're going to go ahead and turn it. And you're going to tighten it to the point that now you're watching that pencil mark, and you're going to tighten it till just the point where this stops to move. In other words, as I tighten this, at some point this will stop moving because that seat went all the way up there, touched that bottom disc, and pulled it up off of this, and then when I spin this, this stops moving. That's the exact point that this has to be equidistant. Once I have those two seats lined up, now I'm ready to put the assembly back together. But before that, I want to do a little test. In other words, before I put water on it and test it and it starts leaking, I'd like to check it before I get it back into the line. So one of the ways that you can test this before you put it back into the backflow assembly and reassemble it, because obviously you've got to put it all back together, put it in the body to make sure you have it equidistant. There's what's called a blow test. Go ahead and make sure that the stems move. By blowing in through the relief valve discharge, you blow in and pushing down on both discs. You should be able to blow and get resistance. In other words, air should not come out. If it was not right, you would blow in and go, and the air would escape like this. So to make sure it's properly sized, if we use that marking, should be able to blow and should be tight like that. All right, clamp bolt gasket goes next. Relief valve spring. Our diaphragm plate. Make sure our two relief valve sensing line holes are lined up like this. And take the time to line everything up. Goes in place, goes in place, grab your bolt. Now, very important when we go to tighten this bolt, because we have to make this bolt tight enough to seal across both diaphragms. That's why they have this Allen head recess in the center there. Go ahead and place your Allen head wrench in there and get your wrench to tighten this bolt. There is no O-ring seal on this bolt like we've been talking about O-ring seals. This has to facilitate a water seal across there, so it's critical that this be very tight through here. It's very, very important to tighten it down. And over the years, unfortunately, some people have tightened it too much and it's broken off like this. But if it wasn't tight enough, it wouldn't seal and it would leak just as bad. So very important that when we go to put that back together, that nut is tight. Let's go ahead and put our relief valve assembly back together. Again, I didn't take the cover off the bottom, so you didn't see me take out a bunch of bolts. But what would happen is the relief valve would come up from the bottom, go in place like this. You would catch your lock nut on the outside. The gasket, which sits on the inside right there, is on the inside of that body. So you'd want to get your lock nut in here and just get this hand tight. Now before I put the cover in place, you keep hearing me say put things hand tight and then get it lined up. Because what I want to do when I get that lock nut in there and just, again, getting it hand tight, like that. All I'm doing is lining it up. You can tell if this relief valve is cocked one way or the other. I'm going to have trouble with the leaking of that gasket. You have to clean the spot the gasket sits on the inside of the body, but I want to get it in there hand tight, line it up. Now I want to get my cover and line up the bolts. So I get my cover, put the bolts in, and go around and tighten my bolts hand tight. Once I've got my bottom plate, relief valve cover plate in place, now I can worry about tightening this nut. I don't want to tighten this nut without the cover in place, because if I do, you can see I can just torque that relief valve body like this. And if I torque it inside the body, you have a good chance of snapping off these two little pins right here. These two little pins position that relief valve so it's in the right place. So I don't want to shear those pins. So I want to have this hand tight, cover hand tight, bolts hand tight before I snug down this lock nut. Check assemblies, whether it's a contained spring version like we've talked about or an uncontained spring version like we have on this particular design. First check disc holder, second check disc holder, second check spring, first check spring. Covers go on. Second check cover. And this is the BAVCO
Model 6C.
The next assembly we're going to discuss is the Model 6CM. This one was known mostly under the Hersey name, not BAVCO this time. Again, the 6CM was the revisions of the 6C where they improved their product to give us a better product. Anyway, 2.5 through 10 inch is what was made. Production began around 1977 and was discontinued around 2004. Rubber parts are still available for all sizes. Hardware parts are limited to stock on hand. Hardware production of parts discontinued just recently. Over the years, they've had several different body configurations. The first and earliest versions were the cast iron bodies in sizes 2.5 through 10. They also produced a bronze body version in 2.5 through 6 inch. The early cast iron bodies that were galvanized had some issues with rusting as the galvanizing wore off. You had raw cast iron, which caused rusting issues, which we'll address when we take the assembly apart. It's important if you had a cast iron or a bronze body that you ordered by that body materials, because the rubber parts were different and not interchangeable. In the later years, the coatings were changed from galvanizing. They went to different types of coatings. From 91 to 92, they used a painted galvanized coating, and then in 92 they switched to a fused epoxy coating as the standard until it was discontinued in 2004. So you may have a galvanized body, you may have a bronze body, you may have a painted epoxy, you may have a fused epoxy, depending which generation of assemblies you had. The 6CM series also produced a reduced pressure detector assembly version called the Model 6CM RPDA in the larger sizes of 4 through 10 inch. They didn't make them in the smaller, meaning 2.5 and 3s, but 4 through 10 inch they produced this. The Hersey Model 2 was their double check assembly. This utilized the same similar check mechanisms as we see on the 6CM in sizes 3, 4, 6, 8, and 10 inch. So their double check was a Model 2. Hersey was nice enough, BAVCO, when they produced a particular assembly, they had a corresponding double check assembly with the same check mechanism. So that's what the Model 2 is, the same check design as the 6CM. Same body construction concerns were galvanizing, painted, or fused epoxy. They did not produce a bronze body version of the double check. And their double check detector assembly was the Model DDC Roman numeral 2. So they produced a double check Model 2, double check detector assembly, DDC2. The RP was the 6CM, and the RP detector assembly was the 6CM RPDA. Here's a picture of the 6CM. Two individual check covers for the checks on top, relief valve cover on the bottom, relief valve drain coming off the side here with an elbow coming off of the body. The number 2 test cock was an issue a lot of times because it was mounted on the relief valve cover, especially with the galvanized body versions. It tended to rust up rather quickly, and the test cock would be plugged. You open the test cock for test purposes, and next thing you know, the relief valve kicks wide open and won't shut off. But anyway, they did have a galvanized version, they had a bronze body version, they had the painted epoxy and fused epoxy version of the 6CM. Model 2, the double check versions, they only had the cast iron body, but they did have the different painted and fused epoxy coatings. The check assemblies did utilize a contained spring design when the covers were removed and the check assembly was taken out in one piece. The spring did stay contained for the average repair and did not have to be replaced usually, or released I mean, so that you did not have to release the spring tension on the check valves. The relief valve, on the other hand, came from the bottom, and stem assembly looked like this. We'll go ahead and take one apart and see what it looks like, but it had a one-piece stem assembly. The relief valve housing would stay inside the body for the average repair. It was unique that it had 2 relief valve seats, an upper relief valve seat and a lower relief valve seat, with a corresponding upper relief valve disc and a lower relief valve disc. So 2 discs, 2 discs and 2 seats on the relief valve was one unique feature of the 6CM. So let's go ahead and take one apart and see what it looks like.
I have a bronze body version here. Here's what it looks like. No shutoffs on it. Our drain line has an elbow here, like the 6C we saw, where the 6C had threads on the outlet. They obviously removed it at this point, knowing that we didn't want to see drain lines connected with solid piping. And just like with the 6C, we see this elbow there, but this does not have to be removed for the average repair. In the 6C, we had to take the drain off because we had to remove that lock nut, but on the 6CM, we can leave this part of the drain just as it is. Let me turn this around so you can see what it looks like as a cutaway. Get a little better idea what this looks like on the inside. This being a 6CM 2.5-inch bronze body version. A couple things that are important is the relief valve sensing line, which comes right along through here. This is where my number 2 test cock would be connected. On the bronze body version, it wasn't so much of a problem, but on the galvanized bodies, where my number 2 test cock was here, and this was my sensing line, if that sensing line plugged up with corrosion and was full of rust, you could see opening that number 2 test cock, the relief valve would kick open, it would never shut off. You'd actually have to drop the relief valve cover and clean out this passageway on the galvanized bodies. They actually had a plastic tube insert available as a retrofit for the galvanized bodies that they do produce if you have one of the older galvanized versions. Obviously, if you got the bronze version like this, that relief valve sensing line should not plug up. First thing we're going to notice that's different about the checks versus the 6cm is that they're tilted at that angle, like this. And what that does by tilting it 45 degrees out of the water passageway is as the check assembly opens up, it makes a much smoother flow of water through the body. Remember the 6C where it came in, went straight up, over, down, over, up, and down? That up and down piping configuration causes a lot of turbulence in the 6C model. By laying the checks down at about a 45-degree angle, streamline the turbulence going through the check bodies. For the repair, we're going to go ahead and remove the check covers. And once we remove a cover, there will be a slight spring tension coming in from underneath, but the springs will be contained on all sizes, 2.5 through 10. So when you take the cover off like this, what you're going to see is the check assembly. You'll notice that there will be 2 or 4 little female thread spots right here on the spring retainer. This is very important when we talk about the 6 through 10 inch. We'll talk about in a minute putting it back together. But on the smaller sizes, 2.5 and 3, not as important. And why those are there is to make sure that we remove the check assembly properly. The trouble with this 45-degree angle is that it makes it a little difficult when we come around to repairing it. It may have given us some nice interesting flow characteristics, but watch what happens. This being a 2.5 inch, I can control the check assembly pretty easily. As I pull the check assembly out, notice that, oops, it can fall down and then come out of the body like that. That may look innocent, but by dragging that guide across that seat, you can see that it's very easy to nick that seat. And unfortunately what happens a lot of times is people pull this out, nick that, and they go, oh, there's what's wrong. The seat has a nick in it. Well, if you take it apart wrong, that will happen. I'll show you a little tool for that in a little while, showing you how to take that apart. But on the smaller ones, knowing that it's at a 45-degree angle, make sure you maintain that 45. This 2.5 inch weighs about 10 pounds. The trouble is the 10-inch version of this weighs about 120 pounds for the first check. So you want to be very careful that you maintain that angle till the guide clears the seat. Now, the seats thread into the body. They're sealed by an O-ring. Special tool will unscrew the seat, put it back in if you have to replace it. For the average repair, 1 bolt holds the disc into the disc holder. They utilized a silicone rubber for the disc. The spring stayed contained, did not have to be released for the average repair. Now, the relief valve stem, what we're looking at is the back of what's called a relief valve housing. And this is the back of what we're looking at right there. On the other side is where that nut is holding the relief valve drain on the outside. So what we're looking at back here is basically this. We're looking at a relief valve stem, our housing. Unlike the 6C, this housing stays in the body. Remember with the 6C, we had to screw the 2 relief valve seats together to get the distance so they're the same as the disc. On the 6CM, we do not have to thread the 2 seats together. They simply slip into place like this. So, going ahead and removing the relief valve, what we're going to do is go ahead and remove all our bolts from the bottom, drop our relief valve cover, and once our cover's off, what we're going to see is this diaphragm right here. By grabbing the diaphragm and moving it back and forth gently, the relief valve stem will come out in one piece. The housing will stay inside the body just like that. Now, inside the housing, what you're going to see is a relief valve seat, just like this, held in with 3 small screws. That relief valve seat is our upper relief valve seat, just like we saw in the 6C version where there's an upper and a lower seat. Our relief valve seat stays in like this, held in by an O-ring. Notice that it looks like it's chrome plated. The seats, stainless steel. The seats are not stainless steel, but they're actually just a chrome plated bronze, and the purpose of that was just to give it a little extra durability, a little coating on the outside to make it a little bit stronger so that the seat would last a little bit longer. So for the average repair, we're going to leave the housing right there. What we're going to do now is take apart the relief valve stem. So, as I say, the seat is replaceable, special tool. Check spring is contained for the average repair. Now we're talking about the relief valve. So here's that housing that we saw there. On the top of the housing will be our relief valve seat sitting inside it like that. Here's what the stem looks like coming from the bottom.
Earlier I mentioned that there was a cast iron and a bronze bodied assembly. These are the relief valve diaphragms of two, the bronze being the smaller, the cast iron being larger. That's why it's critical when you do repair this that you have the correct repair parts, because the parts will not be interchangeable. So, this is what the stem assembly comes out of the body. As I said, you're going to need an Allen head wrench to take this apart. Allen head wrench sits in the top, removing our RV clamp bolt. There will be spring tension underneath, so hold on to the lower relief valve seat very firmly. And as I get to the end of that bolt, I will release the spring tension just like this. Once I've removed the spring tension out of the relief valve, the guide with the bolt will come out in one piece. My relief valve spacer will come out next with my relief valve disc, my lower relief valve seat, my relief valve spring, my clamp bolt, which holds a single diaphragm this time, my relief valve, second relief valve disc here. Clamp bolt has one nut on the back side. To remove the relief valve clamp bolt nut, a lock washer, diaphragm, lower diaphragm plate, diaphragm, upper diaphragm plate, which are interchangeable, our clamp bolt with a clamp bolt gasket. Those are the parts of our relief valve. Now, interesting thing on the relief valve of the 6cm is you'll notice that the relief valve discs do not fit snugly within the relief valve disc holders. You can see that the clamp bolt version, the disc looks like it's thicker than the holder, and on both of them, the OD-ID difference is rather dramatic. It's not a very tight fit. We talked earlier about rubbers and how rubber reacts in water passageways, and the black rubber specifically, the reaction is usually a swelling action. Because the 6cm has two relief valve seats and two relief valve discs that we have to make sure we coordinate the heights of those two seats in relation to the disc, it was critical that they be the exact same distance apart, even if the rubber would swell. So, as a little expansion joint, if you will, had that little extra area so that if the disc did expand, that expansion would not necessarily affect the difference in heights between those two discs. So because the height was so critical, because we had two seats and two discs, it was important that there was an ability of that disc to expand just a little bit because they were utilizing the black rubbers. Okay. Reassemble is going to be just the reverse. We're going to start with our clamp bolt. Going to replace our clamp bolt gasket. Diaphragm plate. Our diaphragm. Relief valve sensing line is internal, so we'll have that extra hole in the diaphragm. Bronze or cast iron, whichever version we have, the diaphragms will be different. Relief valve clamp bolt nut goes on here. We have to tighten this very tightly because, again, it's not an O-ring seal, but what we have is have to make that bolt tight enough to seal across that diaphragm. So it has to be very, very tight. Get 2 wrenches tightening it, not just hands. I'm just doing that for demonstration purposes. Relief valve spring next. We're going to have our relief valve seat, our spacer with the relief valve disc. Going to go ahead, push it down on that relief valve spring, catch our assembly bolt. Tighten our relief valve assembly. The assembly bolt, as the name implies, just assembles it. It's not a water seal. Now, go ahead to rebuilding this assembly. At this point, we've rebuilt our stem. Now we have to take a look at our housing, which does not have to be taken out of the body for the average repair, but I want to show you what's in there. Our upper relief valve seat sits in there with 3 small screws with an O-ring on the back side. If we can inspect the relief valve seat, we can see that the seat is in proper place. There's no reason to remove it for the average repair. The only reason we would remove it if the seat was damaged. Then 3 screws would allow us to take it out and change that seat if necessary. Okay, we're ready to reassemble this valve now, starting with the relief valve. Basically, we've got a blind assembly down here, don't we? In other words, with that cover off, we have to take this stem, come up through the middle, and make sure that guide hits right in the middle of that relief valve seat. That could be quite a problem, because if we miss pushing it in and out, we could take that guide and actually nick the seat. So we want to put the relief valve assembly in first. The reason is because with the check assemblies out, I have a visual into the top of the relief valve housing right here.
So from the bottom, I'm going to go ahead and insert my relief valve stem, watching my guide from here, making sure I can see it okay, making sure that we do not have the guide nick onto that seat. Once I have it in place, we have an O-ring seal that holds this into the housing. In other words, there was no thread that held these in. It's simply pushed into place. So just like all O-rings, we have to make sure the O-ring is lubricated properly. To lubricate it properly, it has to be taken off of there. Lubricant around our fingers, spinning it all the way around. That helps it so when we get it to the cover, that O-ring will squeeze right into the housing. Now, once I have it ready to go back in, I want to place my diaphragm on top of my relief valve cover and put all the bolts around it like this and insert it up in there, because the bolts will help me guide it. Granted, you can't hold all the bolts, but at least get 4 of them in there on opposite sides, so you use the bolts as a guide to line up with the body to try to minimize the contact with this guide. Make sure that you get that relief valve sensing line properly with that extra hole in the middle, so that you don't, because you see if you turn it over one bolt hole, the solid piece of rubber there, you'll never get the relief valve to shut off. So make sure your sensing line is lined up, bolts guiding the cover through there so that we minimize the impact from that guide onto the relief valve upper seat. Check assemblies at this point. One bolt holds the disc into the disc holder, take the bolt off, replace our disc. Putting it back into the body, again, we're having a blind assembly. In other words, I can see the seat fine now, but once I put this in place, I don't see it. So there, I got it in place. What did I just do? Obviously, I just damaged that seat. So I want to be very careful putting the seat back in, the disc holder back in, that I get in the center of that seat. Now again, as I mentioned earlier, when I'm taking it apart on the smaller sizes, 2.5 and 4 like this is relatively easy to do because it's rather easy to hold. But on the 10-inch assemblies, this is a very large and heavy assembly. And maintaining that 45-degree angle through the body is hard to do. On the larger checks, as I said, because of the weight and because of maintaining that 45-degree angle and making sure that those guides do not nick that seat inside there, there is a tool that can be made and utilized for assembling these check assemblies back on the larger sizes. And let's say larger is 6, 8, and 10. I think 4-inch, most people here can handle the weight of that check and maintaining that angle. Remember earlier I mentioned on the back of the disc holder there were 2 or 4 female thread bolts. You'll notice what they're for is to insert eye bolts on the back side, as you see right here. By installing 3 eye bolts, one here at 9 o'clock on the clock face, 12 o'clock, and then at 3 o'clock, 3 eye bolts with a 3/4 inch galvanized T and 3 pieces of 3/4 inch pipe, that 3 people can pick the check assembly up. Here's the 2 for weight, and this is what maintains that 45-degree angle. So that as the check assembly goes into the body, you can insert it in, maintaining it so that you don't damage the seat inside the body. Again, on the back side, there will be the bolt holes depending on the size. 2.5, it's not as important to get it out of there, but that's to maintain that angle as this guide goes into the body. So whether it's a smaller assembly, relatively smaller that we can use my hand like this, or if we have to use that tool that I just showed you we saw on the 10-inch, the check assembly in there so that the guide does not damage the seat right here is important. Now, once we have the retainer, this check assembly in place, you'll notice that the check assembly will move up and down throughout the body. In other words, it sits higher than the flange on here. Again, that weight will be sitting inside the body once the cover's in place. This is more important to know when you go to take it out, especially with the galvanized bodies, because unfortunately with the galvanized bodies, this disc holder would rust to the point and it will not pop up like this. That's important to know because when you go to take it out, it has to come out like that. But if it's a galvanized body and it's rusted in and it's in that position where it's low like this, you're going to have to release that rust bond around the outside. Highly recommend a rubber hammer, slight gently tamping around the outside will release that rust bond along the outside. Because that's all it is that the spring retainer is rusted to the body so that the corrosion's holding it in the body. So removing that's what it's going to be like. Now, go ahead and putting the cover back on. You're going to have 2 different types of seals. The older versions, up till about the turn of this millennium, about 2000, had a gasket, flat gasket that sat on top. The newer generation of assemblies utilized an O-ring cover on the top, and that was utilized in the fused epoxy versions. Whichever version you have, get the appropriate seal, cover bolts on top, just like that. Tighten them down evenly all the way around, whether it's the O-ring seal, which you've got to make sure you don't over-tighten, and then the gasket seal, which has to be tightened evenly for proper seal. And this is the model 6CM.